Hey everybody, and welcome to McArdle Math Academy. In this video we're going to be talking about center of mass again, this time in a two-dimensional case. So we'll look at this example here where we're going to find the center of mass of a uniform triangular region drawn below. So think about this triangle. If we took this out of the plane and held it like a plate, our question is where would we put the fulcrum so that this triangular region would be balanced. And the important thing to look at here is that this thing is uniform. That means that delta is the density is just a constant. It could be 2, it could be 5, it does not matter. And I'll give you some units here. It's kilograms per meter squared. Okay, so what are we after? We're after the center of mass. And the center of mass in this two-dimensional case is going to be an ordered pair x bar, y bar. Using a little bit of logic, we should be able to see that y bar has got to be equal to 0. Because this is a uniform region, the center of mass has to be on this line, y equals 0. So we just got to figure out where the x-coordinate of this center of mass is. Now, we go to our equation for center of mass for x bar. It's the integral, or the sum, the infinite sum here, of the moments, which is the position of each slice that we take, times the mass of that slice. Okay. What's the slice? Well, because we're dealing in the x direction and we have this little position x, we need to draw slices that are vertical slices like this, which have a width of dx. So we're going to be looking at the moments of each of those for this particular region. And then we divide that by the total mass. Okay, so these are the two pieces we need to figure out in order to find what x bar is. So let's take each one separately. We're going to start with the total mass. Well, we're given delta. Delta is a mass density. That's a constant. And we know that that's equal to mass over area. So if we solve this little equation for mass, we're going to get that it's equal to delta times the total area. And this is just a triangular region, so it's 1/2 the base. The base of the triangle is 8 times the height of the triangle would be 4. And by base, what I'm looking at is this as the base here for my triangle. All right, so we find that this is 16 delta. What's delta? We don't know. It's a constant, so we're just going to carry it along. That'll be in kilograms. Okay, second step is going to be to look more at the mass of a slice. Okay, mass of a slice, we use the same formula. It's going to be delta times the area of a slice. And so our job is to figure out what the area of each of these little red slices that I drew above is. So I'm going to redraw the image down here so that we have a little bit more room to work. So give me a second here. So here's our slice. We know that this is 4, this is -4, and this is also 4. So pretty easily we can find that the equation of this line is -x plus 4. And the equation of this line on the bottom here is y equal to x minus 4. Okay, so when we want to find what this total height is, because we're going to need this height to find the area of this slice, it's just going to be this y minus the top y minus the lower function. So minus x minus 4 minus x minus 4. That'll be the height of our slice. So when we talk about area, we'll have the delta here times the height of the slice times the width of the slice, which is dx. So this is the height of the slice. Height of the slice is going to be minus x plus 4, that's the red piece, minus the blue piece, which is x minus 4, all with respect to x. And we just simplify this a little. We're going to get 8 minus 2x dx. Okay, this is what we have for the mass of a slice. All right. So now we're going to go back down to, all the calculus is done here. We just go back to our equation. We put in, we have x times the mass of the slice, which is delta times 8 minus 2x dx. And in the denominator we have the total mass, which is 16 delta. Sorry about that. 16 delta. All right. And we're going to, our x slices run from 0 all the way up to 4. And so we just do this integral out. So I'm going to pull out the 1 over 16 delta. We are going to distribute the x into we'll pull the delta out and distribute the x. And once we integrate, so we'll have the delta here, we have 8x squared over 2 minus 2x to the third over 3, and that's all going to run from 0 to 4. Notice the deltas are going to cancel on me. Alright, and all we have to do is evaluate this, and we end up with 4/3. And this will be in feet. So this is the x-coordinate of our center of mass, which means that our final answer for where the center of mass of this triangular region lies is going to be 4/3. That's the x-coordinate, 0. All right, and let's revisit this at the top, and obviously we'd have units here of feet. So let's revisit this at the top and see what it actually means. Back to our region up here, the location of the center of mass would be 4/3, 0. 4/3 is a little to the left of 1, so it would be this point here, which makes sense because it's closer to the bulky end of the triangle. So here's kind of the bulky end of the triangle. The center of mass is closer to that bulky end than it is to the thinner end out here. Okay, so just make sure that your answers make intuitive sense, and hopefully this helps, guys, and I'll see you next time.